to another one of Sybil's Teacher's Tips. Today we're going to focus on our Invisible Forces Student Activity Pack. When you get your pack, it's going to look like this, and let's dive right in. The very first thing you're going to want to do is take out the bar magnet and one paper clip. All of the little items can be found in a small bag. We want to keep those items away from the bar magnet at first. So have your students get just the bar magnet and one paper clip. Have your students place the bar magnet close to the paper clip and describe to you what they notice, what they feel. They may use the term pull, they may use the word stick. Any of those things are acceptable. Let them tell you what they feel. On their sheet, they're going to have a what's happening where it talks about the word attraction. And that when materials that stick to a magnet or are attracted to a magnet, we call those materials magnetic. So the next part, what they're going to do is, without leaving their seat, and obviously they're going to have a lot more things than I do, but they want to go around and see what is magnetic all in their area and what is not magnetic. After they've done that, have them write a sentence. And we have the sentence starter right here at the bottom. What do they think magnets stick to? What do they think magnets don't stick to? Let them create their answer. They may say things that are shiny. They might say the word metal. We're not sure yet, but let them describe. They may even start to list out the items. That's perfectly okay. The next thing is that they're going to go on almost a scavenger hunt in the classroom. So now they get the chance to get up and move. But before they do that, have them take a look around and predict what they think the magnet might be attracted to, and what are some things that it may not be attracted to. All right? So they're going to go around and they're going to test different items, and they're going to be wanting to look for 4 specific things. And once again, in the paperwork, we prompt them. So they're going to go all around and explore and test all these things all around the room. And the 4 things we want them to think of is: one thing I expected the magnet to attract, and it did. One thing I expected the magnet to attract, and it didn't. One thing I expected not to be magnetic, and it wasn't. And finally, one thing I expected not to be magnetic, and it was. Then we want them to go back to that original definition of what they wrote out, that magnets stick to, magnets do not stick to, and have them start filling it in. At this point, they'll probably start saying magnets are attracted to metal, and then magnets are not attracted to wood, paper. Once again, listing out the things they're not attracted to, which is great. Because then we have a what's happening that talks about exactly what they notice, but it emphasizes that magnets are not attracted to all metals. So let's start exploring some of that. So that comes into our next part. The next part is called Exploring Metals and Magnets, right? So part 1, they were just exploring what was in their seat. Part 2, they went on that scavenger hunt. Now for part 3, they're gonna really look at the metal pieces. So what we're gonna do is we're gonna put our bar magnet to the side. That's definitely important because, as we know, they'll wanna just start testing them right away. And we want them to predict first. So in our little bag of goodies that we have, and to the side, we're gonna get out our piece of aluminum foil. It's a small piece of aluminum foil just like this. We're gonna take out the penny, and we're gonna take out the washer. It's a small little washer, but a lot of them have little hands, so it's okay. And the fuzzy craft stem. They'll be different colors. So have them get those 4 items out. I'm gonna put that paper clip we were using back to the side. Now, Based on those 4 items, have the students make a prediction. What do they think the magnet will be attracted to? Because like I said, a lot of them will say, well, magnets are attracted to metal. Okay? So after they make their prediction, go ahead and start with the aluminum foil. Have the students take the aluminum foil and the bar magnet and place it next to one another. Does the magnet attract the aluminum foil? Record that on their sheet. Then they're gonna move and they're gonna go. So then they're gonna test the penny and the washer and the craft stem. And they're gonna record it in their sheet. We also have a student activity sheet online that they can follow through as well, which just same place you're seeing this video, click under teacher resources and there's a student activity sheet. Okay, so once they go through and they test all of these objects, they describe what surprised them. So many of them might be surprised that the penny doesn't actually get attracted to the magnet, or that the fuzzy craft stem does. But if you look close at the fuzzy craft stem, there's that thin piece of metal right in the middle. Once again, we have a what's happening, and it describes to the students that only metals that are made of iron or contain iron will actually be magnetic. So from there, take a look around the classroom one more time, use your bar magnet to test, and then have the students write down which objects have iron, which objects do not have iron, and describe how they know that. So they're going to go back through based on what they just read, and they should be able to write that this thing is magnetic because this thing contains iron because it's magnetic, going that way. Okay, and that is our first activity. We do want to make sure that you save all of the materials, so I'm just going to set all these materials to the side and we'll get ready for activity 2. So for activity 2, we are going to actually dive into magnetic force. And so I'm going to zoom you in so you can get a closer look at the setup and exactly how to do this. Okay, now that I've got you zoomed in a little bit, I would like for you to go ahead and you're going to take out a paper clip. There are 2 paper clips in your bag. So you're going to take out the first paper clip and you're going to take out the string. The very first thing we're doing is we're creating a floating paper clip. So the students are going to tie a knot at the end of the paper clip. Let your students do this. It may take a little practice, but that's okay. All right. If they have a longer piece of string on the end, go ahead and have them cut that little piece off. Okay. That can change whether or not the paper clip will float properly or not. We've given them more than enough string, so even if they have to tie it a little further in, that's perfectly okay. So now that they have this tied to the paper clip, just like that, they are going to take out of the bag is a double stick tape. So we have a square. Now, you can use regular tape if you'd like, that's perfectly okay, but we wanted to make sure that the students had something to secure the string down to the table. So I'm going to show you how to do that one, and then we'll go from there. All right, so I'm going to cut this into a quarter, okay? And what I'm going to do is I'm going to put the string down first. That's really important. And then I'm going to peel this off. Sometimes these are a little tricky. And I'm going to put the square over top of the string. And just in case you're curious, we do have instructions right here with the pictures, but I wanted to make sure that you saw that it goes over top of the string. Now, this other part can be a little tricky, and you may want your students to work together. However, let them try it by themselves first. So here's my paper clip. Here's my bar magnet. We're going to get close to the paper clip. Don't touch it. And then we're going to lift it up. And I'm going to zoom in here again so you can see that I've lifted this paper clip off of the table. Okay, so we're gonna get close and lift it up. And that's the floating paper clip, how to get it started. Now that we're zoomed in, I wanted to show you again. I'm gonna get close to the paper clip, and you see I'm lifting it up. It's up off the table, okay? Let the students practice that. It can get kind of tricky. And like I said, they might need a partner to help them, but let them see if they can do it on their own first, okay? This is important because what it talks about is that the space between the magnet and the paper clip is part of the magnetic field. So it's starting to bring in that term magnetic field. One thing I want you to remember is we are not introducing terms until after the students have played with something and experienced something, okay? Now that they have seen, oh wow, this field, it's that magnetic field, it's helping lift up the magnet, well, let's see if we can do, if there's anything that might block that magnetic force, okay? So the first thing they're gonna try is an index card. They have an index card. And what they're gonna do is they're going to lift up the magnet, lift up the paper clip, take the index card, and try to go down the middle. If you notice, I'm not touching the paper clip, and the paper clip is still floating. So it discusses how if the paper clip falls, when the index card, just how it fell right now, it's on the table, if it falls between it, then the object blocks the force. However, if the paper clip did not fall, which as we know, with our index card, it did not fall, then it does not block the force. So you're gonna wanna do this with every object. But once again, have your students predict first. So put that magnet to the side. They're gonna be looking at a fuzzy craft stem. They're gonna be looking at aluminum foil. They're gonna look at a paper clip, so that's why there's two in there. So here's your paper clip. And then they're also gonna be looking at the small washer and the penny, okay? Once again, there's a chart on the piece of paper, so have them predict aluminum foil, fuzzy craft stem, paper clip, washer, penny. Which ones do they think will or won't? And then go ahead and test those items. So, once again, get the magnet, get the paper clip floating so you're close, you're not touching, you're gonna pull it up. And then use the penny. See what happens. It's hard to see because I know my fingers may get in the way. Okay? So that gives them the opportunity to test and compare their results to their predictions. Okay? What they should start to notice is that the magnetic field goes through non-magnetic things. So anything that was non-magnetic, the paper clip should still be floating. Okay? Now our next item, we're gonna stay zoomed in, okay? But this is where they're actually going to need to work with a partner because they're going to need 2 bar magnets. All right, now I've got my 2 bar magnets. So like I said, the students are gonna have to work with a partner because they each only have 1 bar magnet. And the very first thing they're gonna do is they're just gonna explore with the magnets. Let them get near each other, see what happens, how do they move, what happens, goes on there. And so then we dive into that one of the forces that is created is a pull, and that's what they've been looking at, right? They've seen a bunch of pulls so far. And so, once again, that's when they are attracted. So a pull is attraction, getting those vocabulary words in there. So we want them to take their magnets and demonstrate a pull. So we're gonna take our 2 magnets, we're gonna demonstrate a pull. And have them try it again. Make sure they got it exactly what they like, okay? Now we want them to notice the letters. All of their magnets have letters on them. We're not so concerned with an N or an S. We just want them to know that, oh, when it pulls and attracts, it's different. The 2 letters are different. Now we're going to introduce for the first time that second type of force, a push, or the word repel. This is the first time they're hearing about this. So we want them to use their magnets to create that push or that repel. Now what's kind of fun about the magnets is they do like to spin. But what's great is if the students hold them and go towards each other, they'll be able to feel that push, that repelling. And we want them to, once again, notice the letters. They might say they're both S's, which is fine. They might say they're both N's. What we want them to know is that they're the same. So if we're pushing, if we're repelling, we are the same. We make sure they draw their magnets so that they have it recorded so that they can go back and take a look. This is where we like to introduce, oops, sorry, that flew in. After they're done, exploring with their magnets and drawing them, this is where we introduce the poles of the magnet. And that in our case, and for most magnets, right, we have a north and a south pole. I should say for all magnets, they have a north and a south pole. And if the magnets with the same poles are near each other, so same poles, two of the same letters, they're going to push each other away. But if the poles are different, they will attract. So really pulling in what happens with those poles and that magnetic force. And that's the end of our second activity. Okay, this next activity I kept us zoomed in because we're going to be working with static electricity. The first thing we're going to do is I already have a balloon blown up. Now, we don't ask the students to blow it up yet, but it's totally up to you. Some teachers prefer to blow up the balloons and just have them ready for their students, or they allow their students to blow it up. So I'm going to set this to the side, okay? We want the students to take out their index card, and they have a pack of paper. So, a pack of pepper, sorry about that. They're going to empty the pack of paper onto the index card. And we're going to take the balloon. Now, if your students haven't blown one up yet, have them blow it up. And they're going to put this near the pepper. Okay? Describe what they notice. Now, they may notice a couple flakes of pepper maybe going to the balloon, maybe none at all. It just depends on have your balloons rolled around your room or what have they touched, okay? But the second thing we're gonna do is we're gonna take that balloon and we're gonna rub it on our clothes. I'm gonna rub it on the carpet real quick for just a couple seconds. And now we're gonna put it next to the pepper. And what do they notice? Oh, this is a good one. Okay, so you can see the balloon really sucks it up. What's great is depending on what clothes the students are wearing, depends on how much static electricity will come up. So the key is for them to see that the pepper, before we rubbed it on anything, the pepper was not attracted to the balloon, right? But when we rub it against the floor or your clothing, you create a static electrical charge. And so we're going to be working with that static electrical charge for the rest of the activity. Now, it is fun to see if the kids can take the pepper off the balloon. What's fun about that is they will get some off, but by rubbing it, they're creating more of a static charge and it goes around the balloon. Now, in your bag, we have given you multiple balloons so that way, if after this activity, if there's, too much, you can always get another balloon if need be. Okay, this next activity is called the dancing string. Now, your bag, your activity bag, will not come with a black piece of paper, but I brought that out so that you could see the string a little bit better. Now, this is the same string that we used in a previous activity, as it's already attached to the paper clip. The paper clip is going to act as the weight. So, what we're going to do is we're going to use our balloon and we're going to charge it. Now, I did not wear the best clothes for charging. Honestly, sweaters are the best. Sweatshirts are good too. All right. But what we're going to do is place the balloon towards the end of the string without trying to touch it. And what do they notice? Right? It's a lot of fun. The string starts to get going. So, once they realize that, oh wow, I'm not touching the string, but that balloon, that static electrical charge is pulling that up, they have two challenges. The first challenge, I'll see if I can get it. A lot of people are good at getting this one, is to make the string stand straight up. Well, all right, without touching it. So, woohoo! There we go. And then the other challenge is how far away can you take the balloon and still get your string to stand up? Oh, and this one's fun to let the kids see where can they go with that. All right. Now, what's really great is once again, we dive into the charges about the charged balloon, because we have a charge here from rubbing it. All right, so static electricity can produce two different charges. Once again, if they have the same, it's going to repel. If they're different charges, it will attract. So they have to think about, does the string and the balloon have the same or different charges? How do you know? They should say it's different because the balloon is pulling the string or attracting the string to it. Okay, so that's part 2. Part 3 has to do with our styrofoam cup. So I'm going to go ahead and get the styrofoam cup out. And at first, the whole goal is to push the cup without touching it. Now, I'm going to show you how to do this, but don't tell your students set the cup to the side. Let your students mess around with it and play, okay? Let them have it upright. Let them turn whatever they want to do until they figure out when it's on its side, it goes, all right? So what's fun is I'm charging the balloon. Oop, lost my balloon. Charging the balloon, pushing the cup, all right? Now, based on this, does the charged balloon and the cup have the same or different? Now, the cup is sometimes tricky, I'll admit. Most of the time it pushes, which is what we want it to do. But if your student does it and the cup starts to kind of go towards it, they can still give you the correct answer, because if it's getting attracted, they have to be different. If it's getting pushed or repelled, it's the same. So have your student demonstrate for you and show you. This next piece, you're going to have the students use work in partners, and they're both going to use their cup. So you will need some tape for this, and you're going to, I like to do a little bit of tape on the bottom to get them to stick. And then, well, that didn't work very well, but tape around the side. There is a little diagram. What you're doing is we're creating like a little axle thing here. Oh. All right, so that when you rub the balloon, it rolls, it pushes, okay? So your students are gonna work on their table or give them a set on the floor or wherever it'll roll. And what you're gonna want, it's a competition, is to be able to push the cup to the other side. So the students will be taking their balloons, rubbing them, and getting it to go. And what's great about this is as soon as they stop and they have to recharge their balloon, it'll start rolling back towards them. This is a great challenge to do on a separate day so that they can talk about and prepare what they want to wear and all of that to get the best push possible. The extension of this is to do it with an aluminum can. Once again, we don't give you an aluminum can, but teachers' lounges have a bunch, and just ask kids to bring one from home. So here's our aluminum can, and same challenge, you're trying to get it to the other side of the table. So they're going to charge their balloon, but you notice that instead of pushing, the aluminum can is attracted to the balloon. So the students will have to go to the opposite side to be able to actually win the challenge of moving the can to their partner's side of the table. So these are two really, really fun challenges. All right, so those were the 3 activities in our Invisible Forces Student Activity Pack. Just as a reminder, there are student activity sheets as well as a Google slide deck with literacy resources underneath the teacher resources page. You'll see a Google slide deck for every single activity, and you will also see the student activity sheets as well. Thanks for joining us.